My name is David Garcia, and I'm going to do the introduction to OSM primitives. So primitives are actions, basically, that are exposed by the operator. But we need to understand first what an operator is before we can get deeper into OSM primitives. So to explain the operator concept, I usually talk about the operator pattern and what it means in the Kubernetes world, okay? So to explain and understand that, let's imagine we have a human operator, okay, that knows everything of a particular application. So is the expert of that application. And as the human operator, it knows how to perform actions. Okay. In this case, just to put a more clear example, let's imagine that the application is MySQL. So this human operator will know how to install the application MySQL. It will know how to configure it, upgrade it, integrate it, do a backup or restore of MySQL, and this list can go on and on. Okay, so the human operator is the expert, and it has all this knowledge about a particular application. So with the operator pattern, what it tries to achieve is to encapsulate all that knowledge of the human operator and put that as code. This means that the human operator could be totally replaced by code, okay? And this code is basically scripts that automate the steps that a human operator would do to perform some operations to the workload. So this operator is called in OSM, we call the operator a charm. So charms are universal operators, okay, that we can use to operate our workloads. As my colleague Mark mentioned before, the reality is messy and mixed, and basically in OSM we will have to deal with a variety of several network functions, physical, virtual, and containerized network functions. And basically OSM needs to take that into account, and it creates the space for the integration work to exist. Okay, so in OSM we can we may want to operate VNFs, and in this particular case the code or the operator's code cannot be inside the VNF. So we have a concept or a type of operator that is called proxy charm, that is code that runs outside of the actual network function, and we operate basically the workload, the VNF in this case, from outside. So OSM will trigger the actions of the operator. The code will run in the proxy charm in this case, and will go against, let's say, the VNF itself. In OSM, these proxy charms can live either in LXD or operators. We support both. Then we also have VNFs that are backed up by clouds or by VMs like OpenStack, AWS, or and so on. So in this case, we may have also VNFs that can be fixed and can have all the software that they need to run, and we may want just to operate the workload from outside of the VNFs. Maybe this VNF exposes an API, and the proxy charm can do some calls to that API in order to operate it. Or we can actually have the code of the operator in the same VNF. So the same VM in OpenStack will have both the workload itself, the VNF, and the operator's code. Although logically, those two things are two separate things, the operator and the application. And then we have KNFs. We can deploy also native charms. So that basically the native charms or the operators will be in the KNF itself, or we can have, as I mentioned before, proxy charms for proxy charm that lives in K8s. Okay, so in the VNFD, the VNF descriptor is basically metadata, charms, and integration. The operations package is called a charm, and it has, as I said, the code needed to manage a specific application. And charms are a great way to operate your workloads since day one of OSM. So in the VNFD, we have, as I said, two pieces. One is the metadata, which is basically declarative YAML, as we saw in the previous session by Alejandro. And there we can describe how many BDUs does a VNF have, also the connection points, and things like that. But then we have the operations code that it's basically the charms that handle the install, update, configuration, integration between applications in a VNFD. And particularly, we will stress on the actions and primitives, which are basically a set of scripts for everyday operations like backup and restore, health check, reset, and things like that. These are called charm actions, and in OSM are called primitives. Also, the VNFD decides which charm actions are surfaced in the UI as OSM primitives, and also can set default parameters for actions in this context. So primitives are basically, as a summary, actions exposed by the operator. And in other words, OSM primitives are actions exposed by the charm, because a charm and an operator, it's basically the same thing here. So now, as I said, but I will repeat this because it's very important to have it clear. Well, there are two different types of operators, proxy or native. So in this case, the proxy, well, I'm going to show the proxy. So we have the workload and we have OSM. So in order to operate the workload, we cannot, sometimes we cannot put the code into the workload, like it's really clear in the VNF example, but also we cannot put that code hard-coded into OSM. So that's why we have this intermediate place that is the operator instance, in which we can put there the code needed that is specific to a particular network function. And we can do there whatever we want. And then, yeah, same thing as before. So OSM will trigger the actions needed, and the proxy charm will call the specific API or whatever in the network function. But also we can optimize our workloads to work with OSM, and basically put the operations code and handle the whole life cycle of the application with the charm so that we could basically install all the software we need and start from a base image with nothing on it. Also, operators are really good for integration. So it's not enough with just being able to deploy workloads and to operate them. It will be very weird to have a complex scenario in which we have only standalone applications and every application works on its own. So in the end, we'll have, like Mark said in the previous example, we could have a WordPress that needs a database, and these are two different pieces of software, and we will need to integrate those somehow. So operators are really good for this, and now we will zoom into one charm and see how the integration works. Although tomorrow we will see this more in detail in the Juju relations session. So this is a charm, basically, and it declares a list of type integration points. So one endpoint can say that it can use a MySQL database. Another one says that it can send the logs to a syslog, and also this one says that it can use an LDAP. And there we have another charm that says that it can provide LDAP as the authentication backend. So this means that integrating endpoints can be related. So the first charm will be related to the second one, and it will get all the data needed to the relation to configure itself to use that other charm. And if we take this concept further, we can build complex compositions by integrating different charm applications. A complex integration example is this one, okay? That is Hadoop, and each one of these charms will have a script to handle a particular life cycle of the application. It will also have they will also have scripts to handle configuration changes, to handle integration, and to handle custom actions of each charm. But it's also important that, for example, there we can see a zookeeper. So we can build one zookeeper operator that can work in different contexts. So as part of different complex integrations, and reuse that same good and well done operator in several applications. So as I said, each one of these will have these all these scripts. So any operation that can any charm can have as many operations as we want, as many actions as we want, and each one of the action will be mapped to a script that will be executed, and basically that script will take some parameters and it will produce an output. In the end of this presentation, I will show some very basic examples to have all these concepts a bit more clear and to understand it a bit better. So in a charm package, we have different types of scripts, and there are some ones that are for the actual life cycle, like installing, configuring, updating, removing, and scaling. Then we have integration scripts a particular charm can be related to many, so it can provide as many endpoints as it wants, and it can also require as many endpoints as it wants, so that, and we will have scripts associated to it to actually configure the charm properly. And then we will have actions, okay, and these ones are just examples. But there's no limit to the things that we can do. Okay, so this is the first part of the presentation. I will now continue with the explaining the basics of the Juju controller. Okay, so until now we have seen what operators are, the things that we can achieve with operators, and now we will give a bit of context about how operators are handled or are managed by OSM to have a clearer picture of what's going on. Okay, so Juju controller is the operator lifecycle manager, and it's basically a core component of OSM. So in the OSM architecture, these are just some of the components. We have the UI, the MVI, the lifecycle manager, that is the LCM, the resource orchestrator. That resource orchestrator is the one that creates the networks in the OpenStack. It creates the VMs there and things like that. And then we have the VCA. The VCA is the Juju controller that actually deploys the charms, and it also runs the actions against the charms and things like that. So all things related to charms are handled by this component that is the VCA. So Juju drives application operations on machine and Kubernetes substrates, and this is quite important because with the same operators, with the same way of writing operators, with the same code, mainly we can deploy applications to different substrates like AWS, MAS, OpenStack, and also Kubernetes. So this is really interesting. And also charms or exposed the same interface in order to interact with charms of different substrates, which makes it very simple to use. Okay, there's one question. Can I use native OpenStack installed in CentOS as Vim and use OSM to do charm action? Can you explain it a bit better? Because I'm not quite sure.
Sorry, I can jump in and answer this quite easily. Yes, OpenStack on CentOS will work the same way anyway. Anyway, it's installed, whether it's the full Red Hat Enterprise OpenStack, the RHOSP, a dev stack from within CentOS or anything like that. OpenStack is OpenStack, and OSM is the one that is controlling the Juju and charmed actions. So it's agnostic of who OpenStack is. In this case, there will be no issues. You'll be able to write your charms, and they will be able to work with the VMs that are launched under CentOS. I've actually I posted a side note in the Hackfest Slack channel. I've also used MicroStack on Microsoft Windows and created an OpenStack that way, and these demos will work there as well.
So yes, it is agnostic of what OpenStack provider you're using.
Okay, thank you, Mark, for asking or answering that. Okay, so let's continue. To understand a bit better the Juju architecture, we have different pieces. So first we have the Juju client that will run in our PC, for example, and we'll talk to the Juju controller that will live in the cloud normally that we are working on, like Kubernetes or OpenStack or whatever. And then we have a concept of model that is basically a way to segregate different application stacks, so we can create as many models as we want, but backed up by different clouds. And in each model, we can have an application stack. So in this case, in this model, we have Kubernetes. These are some of the components needed for a Kubernetes. So each one of these components is charmed, and they have the needed relations between each other to configure themselves. So each one of these charms in the model will have a Juju agent, okay, that will listen, let's say, to the changes of the model. So maybe we have changed the configuration of this particular charm. So the Juju agent will know that and will execute the script associated to that event that is in the code, in the actual charm code, and that will let's say modify or do the changes to the workload. So in OSM, this Juju client is the LCM. So the LCM will act like a Juju client, and it will talk to the Juju controller that is the VCA. So this is basically the VCA. Also, the Juju controller, as I said, it can manage multiple models, and an interesting concept is the multi-cloud concept, and is that the Juju controller can know about many different clouds, and it can add as many models as needed to any of these clouds. So the same Juju controller can be used to, in this example, have this model that is that lives in a K8s cloud, okay, in a Kubernetes, and deploy operators to that Kubernetes, and then have this other model that is backed up by a Vim cloud, an OpenStack, for example, and deploy the VNFs or the operators for the VNFs there. Also, since release 8 in OSM, we introduced the capabilities to have the VCA in HA. So we can scale the VCA, and OSM will be able to talk to that highly available Juju controller. Okay, that's a really good question. Can a charm monitor the workload, VNF or PNF, and take appropriate actions? So the quick answer is yes, you can, but charms are not designed are not designed to monitor. To monitor, we should use Prometheus, and it's the right way of doing it. Okay, but yeah, charms provide basic metrics, and there are some examples of that. I can try to find those out and send those to you. And they can basically provide some basic metrics each or every 5 minutes or so. It's not like Prometheus because charms are not trying to reinvent the wheel and do what Prometheus actually does, but they can provide, yeah. What we can do, and we are going to actually do that tomorrow in the performance monitor session, is to deploy a Prometheus charm and to deploy a workload that expose metrics and relate those two so that that we can see some metrics in Prometheus about the other workload. But we'll do that later. But I think that's out of the scope of your question. So I hope that solves your question. Okay, so perfect. So in general, the VCA coordinates all OSM primitives all OSM primitives and operators. And things that we can do is the VCA can configure the charm, so it can, to put a more clear example, it can set up some variables of the configuration, like the HTTPS proxy to the charm, as a CH certificate, or whatever we want. Then it can also execute actions like do a backup or something like that. It can also tell two charms to relate or integrate, and they will be related, and everything will be, let's say, kind of automatically done. We'll look more into detail the relations tomorrow and also in Friday. So as we said before, the reality is messy and mixed, okay? And operators offer or charms offer a really clean way of an integrated way of deploying operators and handling or operating the workloads using these operators. And what is amazing of this is that with the same kind of structure and with we use the same way to operate different network functions of totally different natures and even vendors. So this gives us a lot of advantages. Okay, now I'm going to actually show how an operator look like, but before I'm going to answer the question that can you work on a multi-cloud environment? Yeah, the quick answer is yes, definitely can. But are you looking to something more specific, or? But yeah, basically yes. You can have one Juju controller that knows about one Kubernetes, one LXD, one AWS account, whatever you can think of, Google Cloud Engine, all that, VMware, and so on. And it can know about all these clouds and deploy charms to any of these clouds with no problem. Yeah. Basically, well, you can have, yes, as Mark said, you can have one for all, or one Juju controller for all the clouds, or one Juju controller in each cloud, as you prefer. Okay, so now I will show some examples of or some basics of the operators. Okay, so these are just steps, okay, that you can actually execute, and you can basically have a first touch with the charms and see how the packages look like and so on. So you can execute the snap install charm craft Edge, okay, and this will install the Charmcraft snap into your PC. And then if you want, you can create a test operator folder, CD to it, and then with Charmcraft in it, you will initialize or create one empty charm, let's say. One charm that has everything it needs on it, but it won't do actually anything. It's just like a template in which you can base on. I will do exactly this on Friday on the first session, I think it is, building operators from the ground up. Okay, I will do all this from scratch, but just for you to have a heads up of what we will be looking at. I'm showing all this now. So you can execute this, okay? And basically, this is the folder structure that you will see created in the test operator folder. So we have actions.yaml, config.yaml, metadata, and inside source, the charm.py. So these are the most important files, okay? Then we have some other things for testing and so on, but those are not really that important for beginners, let's say. And so I will be showing these files now. Starting with the metadata.yaml. The metadata.yaml, it's the place in which we define the metadata of the charm, the name, the description, the summary, and the series that it supports. So in this case, the series is an array of one item that is focal. So this can only be deployed in focal. We can replace this by focal and also Xenial, Bionic, or whatever. I'm pretty sure it supports CentOS also, and so yeah. And then we can put Kubernetes if this is a Kubernetes charm that is not supposed to run in machines, but in Kubernetes. Okay, and I haven't put it here, but this is a place where we put the endpoints or the relations that the charm can provide or that the charm can require. Okay, but I will get into it tomorrow. Then we have the config.yaml that there basically we have inside the options key, we have as many keys as we want. And as an example, I put here log level. So let's imagine we have a config that is log level, and it's basically to set the level of logging that we want to get in a particular application. So the default will be info, but the possible values are all these, okay? And then we define the type there, that in this case is a string. Also, we have actions that are OSM primitives, okay? The same thing. And in this case, I created an action that is create directory. This is the definition of the action. This won't actually do anything, but in the next file, I think we will see the actual code for implementing this action. So in this case, we have create directory. Okay, basically it's an action that creates a directory, and it needs some parameters. In this case, only one, that is the path to the directory that it needs to create. And we said here that this path is required, so that we must set the path. And now we will see the actual code of the charm. So in this case, I'm not showing only the constructor of the charm, and in the charm we specify here in in the constructor how many or what events we want to listen to. So in this case, there are events that or life cycle scripts, let's say, that we talk about later, that are the install, start, update, and things like that. So in this case, I just for simplicity, I only put install, start, and stop. Okay, so we listen for those events, install, start, and stop. Oops. And when those events are triggered by Juju, we will execute these functions, okay, that I will be showing in the next slides. And also, so these first three are three life cycle events, okay, but this is one event for an action, a primitive. That is create directory, is the name of the action that I defined before, underscore action. And when that event happens, we will execute this function that will be defined now. So let's start with the first one. We said that the install event will trigger this onInstall function, and we define that action here. So when we get the install event, this action will run and will do a subprocess run snap install hello, for example. Okay, this is installed just a hello world snap. As simple as that, but here we can put like apt get whatever we want. Apt get, I can come up with any example right now, but as we can install here whatever software we need. We can do a git clone of some repo, install it or build it from source. Whatever we want. In other Hackfest, we did a native charm, or we did a charm in which here in the install part, we installed the inodeb software for, some software, but it doesn't matter. Okay, then we have the start hook or the start event. So here, what we will do is we will do a snap start hello, and in the stop we will do a snap stop hello, and with that we can handle the life cycle of the application. And then let's go to the particular action that is the most important thing here, because this will allow us to do or to implement with no limit a huge number of actions to run against the workload. So in this case, we get from the event object a parameter that is the path, okay? And then we do a make dir -p and then the path that we get in the action. So when we execute the actual action, this code here will be executed. So I hope this makes a bit more clear what the operators are and how are they implemented. Okay, as Mark said before, this is not magic. This is just one piece of code that has several scripts in a very well organized way, and using Python, that is a highly adopted programming language that it's really easy to learn and so on. And basically in each one of, so we can have many scripts, and in each one of the scripts we can handle a particular action. What is the Python environment available for this class? Can we provide the requirements.txt or something similar? Yes, exactly. So if you will want to be in the Friday session, because that one will be very useful. But if you see here, this folder structure, we have the requirements.txt, and there we can have as many Python dependencies as we want. So we include those, all of those there. And in the let me go to the next slide, okay, that is building and deploying the charm. So when we do a charmcraft build command, okay, when we execute this, this tool will build the charm and will get all the dependencies that we define in the requirements.txt included in a virtual environment, so that at deployment time those are there, and at deployment time you don't need to actually get or install any Python dependencies. Okay. So that leads me to the next slide, that is well, executing charmcraft build to build the operator. And then if we are testing, we are not using OSM yet, so we are just testing the operator in an isolated mode. So we can do Juju deploy the path to this file that is generated and is the charm. And that charm will be deployed to Kubernetes, to LXD, or wherever we want. And here I put a note that is important, and is that for the deploy, we need to bootstrap a Juju controller first. We need the controller to be in a cloud, and then that cloud deploy to this, especially to the deeper into Kubernetes. My at the same time as today, I will be covering Juju bundles, that is the way of deploying Kubernetes charms. So that's my slide. Okay, if you want, if you have some questions, okay, yeah, there's a question regarding the role of the Juju agent and so on. Okay, so I think it's this. Okay, so basically we have three things. The Juju client, that is basically when we do Juju deploy, charm, Juju relate, and things like that. But those are just commands that run against the Juju controller. The Juju controller is the piece of software that handles all the charms, all the models of all the clouds, the different clouds. Okay, and then each one of these charms, okay, imagine I do Juju deploy Kafka, okay, as a charm. So that Kafka charm will have the actual code of the charm, okay, and it will have running an agent, okay. So imagine I do with the Juju client, I change the configuration of Kafka, and I say Juju config Kafka log level equal critical, and I change the log level of Kafka. Then the Juju agent will listen to the events happening in the controller, in the model, a particular model, okay. So this Juju agent will trigger the event in the charm code, and the config change event will be triggered. So here in the observes, we can put self.on.config changed, okay, and point that to another function. So in the end, what it will happen is, let me go back, okay? So what it will happen is I will do Juju config and change the config of Kafka, then that will be applied here in the model of the Juju controller, and the Juju agent that is listening to the model, it will trigger the event, okay, here, and the charm code to the config change will be executed. And then in the actual implementation of the config change script, let's say that function, we can get the log level and modify the configurations files of Kafka in order to say, hey, instead of the info log level that you were configured to use before, then apply these changes to that file and use a log level of critical, and then below the Kafka service or whatever is.